Have you ever tried to imagine a machine so massive that a person standing next to it practically disappears? Now, imagine 10 of them, built not to impress crowds at exhibitions, but to tear through mountains, move millions of tons of material, and operate on a scale few machines on Earth can match. Some of these giants weigh thousands of tons, tower over buildings, and were created to handle jobs that would be nearly impossible for conventional equipment. And the further we go down this list, the more unbelievable the dimensions become. But how did engineers manage to make machines this enormous actually move? And just how far did they have to push engineering to keep these monsters working for years in mines and extreme industrial operations? Today, we're taking a journey through 10 of the biggest and heaviest industrial machines ever built. Machines that push the limits of size, weight, and operating capacity. Stay with me until the end. Because when we reach number 1, you'll understand why some machines don't need to be fast to be absolutely mind-blowing. Liebherr R995. Imagine an excavator so massive that even giant mining trucks look smaller when they pull up beside it. Built by Liebherr, a German manufacturer, the R995 was developed for demanding open-pit mining operations, where moving huge amounts of rock quickly and consistently can make all the difference. Depending on its configuration, this giant has an operating weight of roughly 485 tons. In its diesel configuration, it uses a massive 16-cylinder V engine, displacing around 50 liters and producing close to 2,000 horsepower. Acceleration and top speed hardly matter here because this machine was engineered for digging power and productivity. Movement is handled through a hydrostatic drive system, while 2 enormous crawler tracks spread the weight across the ground and provide traction on rough mining surfaces. There is no conventional suspension like you'd find on a truck. Instead, the reinforced undercarriage is built to withstand extreme loads and constant punishment during excavation. Up close, the R995 is dominated by its elevated cab, walkways, massive boom, and huge bucket. The deep rumble of the diesel engine mixed with the sound of the hydraulic system reminds you that this machine wasn't built for speed. It was built to rip enormous amounts of material from the ground, cycle after cycle. Its typical job is loading high-capacity haul trucks in coal, ore, and other large mining operations. The advantage is simple. Fewer bucket passes are needed to fill each truck, keeping the entire mining operation moving efficiently. The R995 also helped establish Liebherr as a major force in the world of giant hydraulic mining excavators. And despite weighing hundreds of tons, it's only the beginning of this list, because the next machine takes size and presence to another level. Komatsu PC7000-11. When a mining operation needs to load enormous haul trucks hour after hour, the Komatsu PC7000-11 is exactly the kind of machine built for the job. Developed by Japanese manufacturer Komatsu and produced in Germany, this hydraulic excavator belongs to the roughly 700-ton mining class and was designed for some of the world's largest open-pit mines. Depending on configuration, its operating weight can exceed 760 US tons. The diesel version uses 2 massive 16-cylinder V engines, each displacing 60.2 liters and producing a combined output of around 4,000 horsepower. A 0 to 60 time is meaningless here. The PC7000 travels at only a few miles per hour because hydraulic power and stability matter far more than speed. Instead of a conventional transmission, engine power drives hydraulic systems that control both digging and movement. 2 enormous crawler tracks provide traction and spread the machine's weight over the ground, while its reinforced undercarriage handles loads that a conventional suspension system was never designed to survive. Its scale becomes even clearer when you look at the bucket. Depending on the application, the PC7000-11 can work with buckets around 47 cubic yards. The elevated cab, broad walkways, and massive rear structure make the operator look tiny when viewed from ground level. In the mine, its mission is to work alongside ultra-class haul trucks and load them in just a handful of passes. That means less waiting time and more ore or overburden moving through the operation, exactly the kind of productivity that justifies a machine this massive. More than 750 tons already sounds difficult to beat, but we're nowhere near the limit. The next excavator takes things even further and shows just how far Liebherr pushed the concept of a hydraulic mining excavator. Liebherr R9800. Now we're entering a category where an excavator starts looking more like a moving building. Introduced by Liebherr in the late 2000s, the R9800 was created for massive open-pit mines, where every digging cycle needs to move tremendous amounts of material without sacrificing stability or precision. Depending on configuration, its operating weight exceeds 880 US tons. One of its best-known diesel configurations uses two 16-cylinder V engines, each displacing roughly 60 liters, with combined output around 4,000 horsepower. Speed is secondary here because that tremendous power exists primarily to drive an equally massive hydraulic system. The machine uses a hydrostatic drive rather than the conventional transmission you'd find in a truck. Two huge crawler tracks support its weight, provide traction, and allow it to move across demanding mining terrain. Its reinforced undercarriage acts as the rigid foundation needed to withstand the forces generated during every digging cycle. Certain configurations can use buckets exceeding 52 cubic yards, allowing the R9800 to move tens of tons of material in a single pass. From the elevated cab, the operator controls a machine covered in stairs and walkways with a body so massive that someone walking alongside it nearly disappears. In mining operations, the R9800 is paired with ultra-class haul trucks, reducing the number of passes required to fill each one. Less waiting means more material moved and productivity that smaller equipment simply can't match. If you're enjoying this journey through some of the world's biggest industrial machines, hit the like button, subscribe to the channel, and turn on the notification bell so you don't miss the even bigger machines coming next. And if an excavator weighing more than 880 tons already seems beyond normal scale, get ready. The next machine leaves the traditional hydraulic excavator behind and enters a world dominated by cables, electricity, and monumental steel structures. P&H 4100 XPC. From this point on, the scale changes dramatically. The P&H 4100 XPC, developed by the legendary P&H mining equipment brand, now part of Komatsu, was designed for enormous open-pit mines, primarily loading haul trucks capable of carrying hundreds of tons per trip. This electric mining shovel can weigh around 1,500 US tons, depending on configuration. Instead of relying on one giant diesel engine, it receives external electrical power and uses powerful electric motors to operate its hoisting, swinging, and propulsion systems. Engine displacement, conventional engine torque, and 0 to 60 acceleration simply don't apply here. Its drive systems are electric, with large motors controlling the machine's major functions. Two enormous crawler tracks distribute the weight and allow the shovel to slowly reposition itself around the mine. Its rigid, heavily reinforced structure is designed to withstand the punishment of thousands upon thousands of loading cycles. The centerpiece is the giant dipper operated through heavy steel cables. Depending on configuration, it can move more than 100 tons of material in a single pass. The sound of powerful electric motors, tension cables, and the dipper hitting rock creates an experience completely different from a conventional hydraulic excavator. In practice, the 4100 XPC was designed to load massive haul trucks quickly, minimizing the time between cycles. Machines like this have become essential in major copper, coal, and ore operations where reliability and production capacity matter just as much as brute force. We've now crossed well beyond the 1,000-ton mark, and we're still nowhere near the heaviest machines on this list. The next one comes from another era, but its incredible size turned it into a mining celebrity. Big Brutus excavator. Few machines combine industrial gigantism and American mining nostalgia quite like Big Brutus. Built by Bucyrus-Erie in the early 1960s for the Pittsburgh and Midway Coal Mining Company, it went to work in Kansas as a massive electric shovel designed to remove the overburden covering coal deposits. Big Brutus weighs more than 5,000 US tons and stands roughly 160 feet tall. Instead of a conventional diesel engine, it relied on external electrical power to operate its enormous motors and mechanical systems. Engine displacement, engine torque, and 0 to 60 acceleration don't apply. This machine moved slowly because its job was to dig, not run. Its propulsion system was electric, with gigantic crawler tracks supporting all that weight. The bucket held roughly 90 cubic yards and could remove around 100 tons of material in a single cycle. Every movement required tremendous power, balance, and precision to control a structure of this size. Standing beside Big Brutus feels more like standing next to an industrial building than an excavator. The operator's cab sits high above the ground, walkways run through the structure, and its cables, motors, and machinery bring back the atmosphere of America's giant mining operations of the 1960s and 1970s. Big Brutus spent its working life stripping away overburden to expose the coal underneath. When it was no longer economically practical to operate, it could easily have been scrapped. Instead, it was preserved and today survives as a museum attraction in Kansas, becoming one of America's most recognizable pieces of mining history. And if a shovel weighing more than 5,000 tons already seems impossible to top, the next machine takes cable-operated excavation to an even more brutal scale. Silver Spade. The Silver Spade was built by Bucyrus-Erie and entered service in 1965, working the coal fields of Ohio. Its job was to strip away enormous amounts of dirt and rock covering the coal seams, a task that demanded tremendous power, reach, and a scale far beyond ordinary mining equipment. Its weight was in the neighborhood of 6,000 tons, with a structure rising dozens of feet into the air. It was completely electric, using massive electric motors to operate its swing, cables, and digging mechanisms. That means engine displacement, conventional engine torque, and 0 to 60 acceleration don't apply to this giant. Movement was extremely slow and used only to reposition the machine around the work site. Speed was irrelevant. Everything was designed around stability and digging power, because moving a structure this enormous required careful control. Its giant bucket could move more than 100 tons of material during certain digging cycles, while enormous steel cables handled the incredible loads involved. Every pass removed a huge amount of overburden and helped expose the valuable coal seams below. From ground level, the Silver Spade looked like a complete industrial complex. Its boom dominated the skyline, the cab looked tiny by comparison, and the sound of electric motors and heavily loaded cables made the forces involved impossible to ignore. Even more impressive, it didn't need to travel long distances to remain productive. Most of its work was done from a relatively fixed position, using its tremendous reach to excavate a broad area without requiring a constant stream of trucks to move every load. For decades, the Silver Spade became an icon of Ohio mining and eventually achieved legendary status among heavy equipment enthusiasts. Attempts were made to preserve it after retirement, but structural problems and enormous maintenance costs ultimately led to much of the machine being dismantled. And if a machine weighing thousands of tons already sounds excessive, the next one proves that mining engineers were still willing to push the scale even further. Bucyrus-Erie 2570WS. The Bucyrus-Erie 2570WS was created in the United States to handle one of mining's toughest jobs, removing enormous quantities of dirt and rock covering valuable coal seams. It was a giant dragline built for open-pit operations where conventional equipment simply couldn't match its productivity. Its weight reached several thousand tons depending on configuration. External electrical power supplied massive electric motors that controlled hoisting, dragging, and swinging. There was no traditional diesel engine, conventional displacement figure, or 0 to 60 acceleration to talk about. There was no conventional transmission either. The machine repositioned itself slowly using a walking mechanism that moved the enormous structure in small steps. This was necessary because ordinary wheels or crawler tracks would have faced enormous challenges supporting a machine of this mass. Its defining feature was the giant boom combined with a bucket suspended from steel cables. The bucket could reach far from the machine, drag huge quantities of material across the ground, and dump it well away from the excavation point, reducing the need for trucks to haul every load. Inside, the main structure resembled a small industrial plant, packed with motors, drums, electrical equipment, and massive cables. Outside, the operator's cab looked tiny beside the boom and steel structure towering over the mine. In practical terms, the 2570WS removed overburden and opened access to the mineral layers underneath. Its real strength was the ability to repeat that process for hours, moving tremendous amounts of material with enormous reach. Machines like this defined an era when American mining companies invested in increasingly massive equipment to lower costs and raise production. But even compared with a dragline this huge, the next machine went further and became one of the absolute giants of mining history. Marion 6360, the Captain. Few industrial machines ever received a nickname more fitting than the Captain. Built by Marion Power Shovel in the United States, this enormous dragline entered service in 1965 and worked in the Illinois coal fields, stripping away the dirt and rock covering the coal deposits below. Its weight reached approximately 12,700 tons, placing the Marion 6360 among the heaviest land-based machines of its era. It relied on external electrical power and massive electric motors to operate its hoisting, dragging, and swinging systems. There was no traditional transmission or meaningful 0 to 60 time. Movement was incredibly slow and accomplished through a walking system designed to reposition thousands of tons while maintaining control and stability on the mine floor. Its bucket held more than 170 cubic yards and could remove hundreds of tons of material in a single cycle. Suspended by steel cables from a gigantic boom, it could work across a huge area without requiring the entire machine to move after every pass. Up close, the captain looked like an entire industrial facility. The cab, motors, cable drums, and monumental boom completely dominated the landscape, while the sound of the electrical systems and heavily tensioned cables made its sheer scale impossible to ignore. Its career ended in 1991 after a major fire severely damaged the machine. Repairing it would have been enormously expensive, so the captain was eventually dismantled. Its name, however, remains legendary among fans of heavy mining equipment. And even a dragline weighing more than 12,000 tons doesn't take the top spot. The next machine abandons the traditional excavator concept and turns an entire industrial structure into something capable of moving across the ground. F60 Overburden Conveyor Bridge. Now the scale changes completely. Built in what was then East Germany, with the first F60 units entering service around the end of the 1960s, these machines were designed for massive open-pit lignite mines. Their job was to continuously transport the overburden removed from above the coal seams. At roughly 1,140 feet long and around 13,000 metric tons, depending on the specific unit and configuration, an F60 is comparable in length to an enormous ship sitting on dry land. Its systems are electrically powered, with large motors driving the wheels, conveyor belts, and auxiliary equipment. Engine displacement and 0 to 60 acceleration simply aren't relevant here. Instead of crawler tracks, the F60 travels on large sets of wheels mounted in massive bogie assemblies, slowly moving through the mine. Its speed is extremely low, but that doesn't matter. Its purpose is to transport thousands of tons of material continuously through its gigantic conveyor system. Visually, its length is almost difficult to comprehend. Walkways, towers, cables, and conveyors stretch so far that from a distance the machine appears to cut across the landscape. When it's running, the constant sound of electric motors and conveyor belts makes it feel like an entire factory is moving. In operation, the F60 receives material removed by excavators and carries it across large distances before dumping it into previously mined areas. That greatly reduces the need for haul trucks and allows material to flow continuously through high-production lignite mines. One preserved F60 in Germany became an industrial attraction, largely because its dimensions are almost impossible to appreciate until you're standing beside it. Walking across the structure feels more like crossing a gigantic steel bridge than touring a piece of mining equipment. And even at nearly a third of a mile long, the F60 still doesn't take first place. The final machine combines enormous weight, height, length, and digging capacity on a scale that completely changes what the word giant means. Bagger 293. At the top of our list is a machine that practically redefines industrial scale. The Bagger 293 was built by Germany's Tackraft and entered service in the 1990s, working in Germany's enormous lignite mines, where its job is to continuously remove colossal quantities of material. It weighs roughly 14,200 metric tons, stretches about 740 feet long, and stands nearly 315 feet tall. Instead of a conventional diesel engine, it receives external electrical power to operate dozens of motors responsible for excavation, conveyor systems, and movement. There is no traditional transmission or meaningful 0 to 60 time. The Bagger 293 moves on enormous crawler assemblies at an extremely low speed because stability matters far more than speed when you're trying to move thousands upon thousands of tons of steel. Its defining feature is the enormous bucket wheel mounted at the A front of the machine. The buckets work continuously, cutting material from the ground and dumping it onto internal conveyor belts, essentially turning the entire machine into a moving excavation and production line. Standing beside it feels like looking at an industrial complex that somehow learned to move. Walkways, staircases, platforms, cables, and motors cover the structure, while the constant sound of conveyors and electrical systems reinforces just how far removed this machine is from ordinary heavy equipment. In practical terms, the Bagger 293 was designed to keep enormous mining operations running continuously while reducing dependence on fleets of smaller machines. Its dimensions and productivity have made it one of the most recognizable symbols of extreme heavy engineering. And that's how we reach the top. Thousands of tons of steel, nearly 315 feet tall, and dimensions worthy of an entire industrial complex. The Bagger 293 doesn't just finish this list, it shows how far engineering can go when size and productivity are pushed to the extreme. After seeing giant hydraulic excavators, legendary draglines, and industrial structures weighing thousands of tons, one thing is clear. These machines were built to work on a scale that ordinary equipment could never match. They're more than just massive machines. They represent decades of engineering and heavy mining history, taking on jobs that would be nearly impossible for conventional equipment. Now tell me in the comments, which one impressed you the most? Which of these machines did you already know about? And which one would you most like to see operating in person? If you enjoyed the video, hit the like button, subscribe to the channel, and turn on the notification bell. That tells YouTube this content is worth recommending and helps the channel reach more people who love giant machines just as much as we do. I'll see you in the next video.